Welcome to the Sleepy Astronomer, where we drift gently through the stars, one soothing thought at a time. As we float into the quiet wonder of space tonight, I'd love to know, where in the world are you watching from? Are you wrapped in blankets in a quiet room? Or maybe you're stargazing somewhere under the open sky? Wherever you are, you're in the right place. Let's settle in, breathe deeply, and explore one fascinating question. Could you hear anything in space? Out in the vastness of space, where stars are born and galaxies drift like islands in a cosmic sea, something strange and surprising happens. There is no sound. Not a whisper, not a murmur, not even the faintest echo. Space, for all its beauty and mystery, is profoundly silent. It's a silence so complete, so absolute, that even the loudest explosion would vanish into nothingness without ever being heard. This can feel a little unsettling at first. After all, we live in a world filled with noise. On Earth, sound is part of our every moment. The rustling of leaves, the hum of a refrigerator, the rise and fall of a human voice. Even in the quietest room, you might still hear the distant bark of a dog, or the faint pulse of your own heartbeat. But in space, none of that would reach your ears. It's not that the universe is quiet in the way a forest might be at night. It's quiet in the sense that it's physically impossible for sound to exist the way we know it. To understand why, we need to think about what sound really is. Sound is the movement of vibration through a medium, like air, water, or even solid ground. When someone speaks, their vocal cords vibrate, pushing the air around them in waves. These waves travel through the air until they reach your ear, where they're translated by your brain into what we understand as sound. But space doesn't have air, or water, or ground. It's a vacuum, a place so empty that even individual atoms are few and far between. Without a medium to carry sound waves, there's simply nothing for those vibrations to travel through. It's like trying to shout across a canyon where the air itself has disappeared. You could scream as loudly as you want, but no one on the other side would hear you. Your voice would never leave your mouth. It would die there, in the void, unheard. Imagine floating outside a spaceship, watching a distant star flare to life in a magnificent supernova. The light would reach you, bright, blinding, brilliant. But the sound? There would be none. No booming explosion, no crashing roar, just silence. Deep, all-consuming silence. And yet, that silence has a kind of poetry to it. It's not a silence that feels empty or cold. In many ways, it's comforting, calming, like being wrapped in a warm blanket made of starlight. The absence of sound allows your mind to wander, unburdened by noise, free to drift like dust through the Milky Way. In that silence, you might even begin to hear something else, not with your ears, but with your imagination. You might hear the quiet rhythm of your own breath inside a space helmet, the gentle thump of your heartbeat, the soft mechanical hum of life support systems keeping you safe. But beyond that, beyond the walls of your suit or ship, there is only stillness. Some astronauts have spoken of this silence with awe. They describe it as both alien and strangely peaceful. Being in space, they say, is like being in a place outside time, where the usual rules no longer apply. It's as if the universe is waiting, watching, holding its breath. And perhaps that's part of what makes space so magical. In its silence, it gives us room to think, to feel, to dream. The silence of the stars invites us not to listen with our ears, but with our hearts. So if you ever find yourself wondering what it would be like to drift among the galaxies, remember this: space won't speak to you the way Earth does. It has no birdsong, no waves, no wind, but in its silent embrace, it may just say more than any sound ever could. Before we can truly understand why space is silent, we have to understand how sound works here on Earth. Our cosy little planet, filled with invisible currents of air, water, and vibrating matter. Sound may feel simple to us, something we experience from the moment we're born, but behind every whisper, every song, every crashing wave is a delicate and fascinating dance of energy. Sound begins with movement. Imagine a violin string being drawn by a bow, or vocal cords vibrating as someone speaks, or the tip of a falling raindrop striking the surface of a puddle. Each of these actions causes a tiny disturbance, a vibration that moves outward in waves. These waves push and pull the molecules around them. Like ripples in a pond, the vibration spreads out through the medium, through air, water, metal, or any other substance that has particles packed closely enough to bump into one another. Take a moment to picture this. A bell rings in a quiet room. The clapper inside strikes the side of the bell, and the metal begins to vibrate. These vibrations shake the surrounding air molecules, which then bump into other air molecules, passing along the energy in a series of pressure waves. These waves travel through the air until they reach your ears. Inside your ears, your eardrums begin to vibrate in response. These tiny vibrations are then translated by your brain into the sound of the bell ringing. All of this happens in fractions of a second, so fast that you rarely stop to think about the miracle of it. What's important to understand is that sound is not a substance. It doesn't travel like a beam of light or a cloud of smoke. It needs something to move through. It's like a relay race that can only happen if each runner has someone to pass the baton to. Without a chain of closely connected particles, the waves simply can't move. No particles, no vibration. No vibration, no sound. Different materials carry sound at different speeds. Air, being relatively light and loose, carries sound at about 343 meters per second, roughly 1,125 feet per second. That's fast, but not as fast as in water, where particles are more tightly packed. In water, sound travels at over 1,400 meters per second. In solid steel, it can travel at more than 5,000 meters per second. The denser the medium, generally, the faster sound can move through it, because the particles are closer together and can transmit the vibration more efficiently. This is why you can hear someone's voice through a wall or feel a train coming by, placing your ear on the track before you see or hear it in the air. The wall, the rail, the water, all of them act as messengers for sound. You can even see sound travel sometimes, though we don't often think of it that way. A subwoofer pumping out bass causes nearby surfaces to tremble. You can feel the beat in your chest at a concert. A glass of water might ripple with each boom. Those are sound waves in action, shifting molecules with every pulse. We also shape and interpret sound in endlessly complex ways. Our ears are finely tuned instruments. They can pick up the difference between a whisper and a roar, between the joyful squeal of a child and the distant rumble of thunder. Sound is deeply tied to our emotions. A familiar song can bring back 1,000 memories. The tone of someone's voice can comfort or frighten, charm or annoy. Sound is more than physics. It's a human experience, deeply woven into our minds and bodies. Even animals, from elephants to bats to dolphins, rely on sound in remarkable ways. Whales sing across entire oceans. Bats navigate in pitch black by bouncing sound waves off their surroundings, creating a picture of the world through echoes. Birds call to one another across treetops. Wolves howl under the moon. Nature, in many ways, is a symphony. But take all of this, every wave, every echo, every vibration, and ask, what if there were no medium, no air, no water, no solid ground? What if there were just emptiness? That is the difference between Earth and space. Here on Earth, sound surrounds us in every waking moment. It tells us where we are, who is near, what is happening. It's a kind of language shared not just between people, but between us and the world. Thunder tells us a storm is coming. Laughter tells us joy is nearby. Even silence has meaning, because we're always expecting sound. That expectation doesn't carry into space. And so, to truly appreciate the stillness of the cosmos, we must first grasp the miracle of sound on Earth. The gentle choreography of energy moving through invisible webs of particles. The quiet journey from a vibrating source to the depths of our consciousness. It's something we take for granted until we leave the world behind. As we journey further from Earth and drift slowly into the vast, inky blackness of space, we begin to notice something strange, something our bodies are not used to. It's not just the absence of gravity or the view of stars without twinkling. It's not the eerie stillness or the lack of wind brushing against our skin. It's something deeper, more subtle, a silence so complete that it feels like even time has stopped moving. This is not just silence as we know it. It is the absence of sound itself. To understand why space is so different, we have to understand the nature of a vacuum. When we say that space is a vacuum, we don't mean it's completely empty, though it's very, very, very close. There are still particles out there, hydrogen atoms, stray photons, and occasional bits of dust or gas. But they're spread so thinly across such enormous distances that for all practical purposes, space is an ocean of emptiness. The average distance between molecules in the vacuum of space can be measured in meters. In contrast, here on Earth, even the tiniest volume of air contains billions upon billions of molecules, bouncing and vibrating, ready to carry sound. Sound, as we explored earlier, needs a medium. That medium can be solid, liquid, or gas, something with matter, with particles that can bump into each other and pass vibrations along like a message in a bottle. But in space, the particles are too few and far between. There's no tightly packed chain of molecules to carry that message. If someone were to shout just a few feet from you In the vacuum of space, even at the top of their lungs, you wouldn't hear a thing. The sound would have no path to reach your ears. Their voice would vanish before it ever began to move. Even dramatic events, collisions between asteroids, the ignition of rockets, or the fiery collapse of a dying star, take place in perfect, terrifying silence. These are events that, on Earth, would be deafening, but in space, they are quiet. No matter how loud the event should be, if there's no medium to carry the sound, it's as if it never existed in the first place. To make this more vivid, imagine an explosion in space, a spacecraft engine detonating, or a meteor crashing into the surface of a barren moon. Flames might blossom outward, debris might scatter in slow, graceful arcs, and light might flash in all directions. But you would hear nothing. You would see the event, yes, but not feel or hear the shockwave. It's like watching a silent film with the sound turned off, except the sound was never there to begin with. It's also why astronauts outside their spacecraft must rely on radios and other communication devices to speak to one another. Inside their helmets, sound can travel through the air in the pressurized spacesuit. Vibrations from their voices move through the air, in the helmet, through their suit and into the microphone. The radio then transmits the signal using electromagnetic waves, which can travel through the vacuum back to the receiver in someone else's helmet, where it's converted back into sound waves within the tiny, pressurized atmosphere of the suit. It's a clever workaround for a place where sound naturally cannot exist. There's another factor that makes space feel even more foreign. It's not just silent, it's insulating. Without particles to carry heat or pressure, space feels cold and empty in more ways than one. There's no breeze, no flowing current, no tactile presence. On Earth, even in silence, you still feel the presence of the world around you, the weight of the air, the pressure on your skin, the subtle cues that remind you you're surrounded by matter. In space, those reminders disappear. The psychological effects of this can be profound. Some astronauts have described feeling an intense sense of isolation when performing spacewalks. It's not just the visual emptiness, but the absolute stillness. The inability to hear the environment, no footsteps, no background noise, no sound of the breeze or birds, can make a person feel as though they've stepped outside of reality itself. It is a silence so deep that it becomes almost spiritual or surreal. You're floating in the universe, surrounded by millions of stars, yet everything around you is still and soundless. In science fiction, this truth is often ignored. Movies and TV shows love to add drama with the thunder of engines, the roar of explosions, or the shriek of flying debris. But the real cosmos doesn't sound like that. It's vast and silent and slow. Its drama is visual, not auditory. The only sound is the gentle hum of your own breath, the soft rhythm of your heartbeat, and maybe, just maybe, the quiet buzz of your thoughts. That contrast between what we expect and what actually exists in space is part of what makes it so mesmerizing. Our senses are grounded in Earth's environment. Our brains are wired to interpret vibrations as sound, to respond to noise and rhythm. But space invites us to leave that behind. It challenges us to listen differently, not with our ears, but with our minds. It asks us to feel the world in new ways, to find music in motion, poetry and silence. So when we say that space is different, we're not just talking about physics. We're talking about perception, experience, and the deep transformation that occurs when you leave behind the world you know. In that sense, the silence of space isn't a lack of something. It's the presence of something else entirely. A stillness so profound that it opens a door to awe, wonder, and reflection. And perhaps in that endless quiet, we're not missing sound at all. Perhaps we're simply hearing the universe in its own native tongue. In our imaginations, and certainly in the world of cinema, space is loud. We've all seen it. Massive starships screaming through the void, weapons unleashing thunderous blasts, and distant planets erupting in fiery explosions that seem to shake the entire galaxy. The soundtracks are gripping. The audio design is full of deep rumbles and high-pitched whines. It's dramatic, it's powerful, and it's completely wrong. This is one of the biggest myths about space, an illusion lovingly crafted by filmmakers to heighten the emotional tension of their stories. But the reality couldn't be more different. If you were actually there, witnessing one of those grand cosmic events from the safety of your spacesuit or through the window of a spacecraft, you would hear absolutely nothing. The mighty explosions would play out in complete and utter silence. It would be haunting. It would be surreal. And it would be one of the most beautiful and eerie things you've ever seen. Hollywood has always taken liberties with physics. After all, silence doesn't sell popcorn. Audiences want to feel what's happening. They want the boom of a battleship being destroyed, the satisfying crackle of a laser beam slicing through the void, the epic crescendo of a star going supernova. And so, sound designers do what they do best. They create rich, layered audio environments to match the visual spectacle. Even when the setting is space, which should be silent, we are given the comforting illusion of noise. But real science doesn't work that way. If you were floating just outside a ship during a space battle, the kind you see in sci-fi movies, you wouldn't hear the blasts. You might see a bright flash of light as something explodes. You might feel a tremor through your suit if you were physically connected to the structure being hit. But you wouldn't hear a thing through the vacuum of space. The sound waves have nowhere to go. There's no air, no water, no solid medium to carry them. They'd be born, and then die immediately, without ever travelling an inch. And yet, it's easy to understand why movies depict space as noisy. Silence can be unsettling. In fact, studies have shown that people become anxious when scenes are completely silent, especially during action sequences. Silence can create discomfort, even fear. So instead of facing that silence, movies use music and sound effects to guide our emotions. The roar of an engine tells us that a ship is powerful. The blast of a weapon makes it feel dangerous. The deep bass rumble of a distant planet being destroyed tells us that something enormous and tragic has just occurred. This isn't just storytelling, it's sensory manipulation. Our brains are used to linking sound with sight. When something crashes, we expect a boom. When something speeds away, we expect the whoosh. Even though space doesn't behave this way, we instinctively fill in the blanks. Hollywood simply leans into that instinct. But what happens when we try to imagine these scenes without the sound? Picture this. A massive spacecraft drifts silently past, lit by the cold light of a distant sun. Suddenly, one of its engines bursts into flame. Debris is thrown into space in slow motion, tumbling, spinning, glowing, and not a single sound escapes. There is no roar, no scream, no thunder, just motion, just light. The vacuum swallows every sound before it begins. And in that stillness, the moment becomes strangely beautiful, haunting, almost sacred. That's what real space is like. Visual, silent, timeless. There have been a few films and documentaries that tried to portray this truth more accurately. 2001, A Space Odyssey, for example, famously embraced the silence of space. In many scenes, as the camera pans over vast spacecraft and distant moons, there is no sound at all, just the hum of a classical score, or sometimes nothing but breathing. And in those moments, the silence becomes more powerful than any explosion. It makes you feel small. It makes you feel like you're really out there, alone in the cosmos. Astronauts who have actually travelled to space often talk about this in their reflections. They say that one of the most striking things about being in orbit is not the view, but the quiet. The sudden absence of Earth's background noise. The realization that you're moving at thousands of kilometers per hour through complete stillness. Even on board the International Space Station, where machines hum and fans blow, astronauts can sense the difference. Outside, beyond the hull, is an infinite silence. What does that silence do to the human mind? It depends. For some, it's peaceful. The absence of noise allows the mind to rest. Thoughts become clearer. Focus deepens. For others, especially during spacewalks, the silence can feel overwhelming, like stepping out of the world and into something alien, unfamiliar. The lack of sound strips away all distractions and leaves you alone with your thoughts, floating in a sea of blackness and stars. It's easy to romanticize silence when we talk about space, but we should also respect how strange it is. Our entire lives have been filled with sound. We rely on it constantly, for communication, for orientation, for connection. When that disappears, we have to find new ways to feel grounded. That's why, inside spacecraft and spacesuits, engineers go to great lengths to preserve a sense of normalcy. Air circulates, fans run, radios crackle. These sounds aren't just practical, they're psychological. They remind the astronauts that they are still alive, still human, still part of a world that makes noise. Because outside, just a few inches away, the universe is waiting, and it will never speak to them. So the next time you see a spaceship explode in a movie and hear the satisfying boom, remember that it's only part of the illusion. In reality, space doesn't boom, it doesn't roar, it doesn't whisper, it doesn't even echo. It simply watches and listens and waits. When we think about astronauts venturing out into the endless expanse of space, a natural question arises. What do they actually hear? Outside the protective bubble of their spacecraft, beyond the thin walls of their helmets, space is silent. But inside their suits, things are very different. Astronauts do hear sounds, just not the ones we might imagine. Spacesuits are marvels of engineering, designed not only to protect the wearer from the harsh environment of space, but also to support all the vital functions necessary for life. Among their many features, these suits create a small, pressurized atmosphere around the astronaut, filled with breathable air. This atmosphere inside the suit allows sound waves to travel, enabling astronauts to hear their own voices, the faint hum of their breathing, and the subtle noises generated by their suit's life support systems. Because there is no external air to carry sound waves, astronauts can't hear the roar of a rocket or the crackle of a solar flare outside their helmets. Instead, what they hear is a world all their own, a symphony of subtle, mechanical, and biological sounds that remind them they are alive and connected, even when surrounded by a vacuum. The quietest sound an astronaut hears is often their own breathing. Enclosed within the helmet, each inhale and exhale creates a soft rhythm, a comforting metronome marking the passage of time in an otherwise alien environment. This breathing is not just a necessity, but a deeply grounding presence, a reminder of the life sustaining their fragile body. Alongside breathing, there is the steady pulse of the suit's systems, the fans that circulate air, the pumps regulating temperature and pressure, the electronics managing oxygen supply and communication. These sounds can be faint or more pronounced, depending on the suit design and the task at hand. Some astronauts describe these noises as a kind of white noise, a constant mechanical heartbeat that becomes almost hypnotic over time. Another fascinating source of sound inside the suit comes from the communication system. When astronauts speak to each other, or to mission control, their voices are picked up by microphones inside their helmets. The radios then transmit these sounds via radio waves, which can travel through the vacuum of space. At the receiving end, these radio signals are converted back into sound waves, allowing clear communication despite the silence outside. Sometimes, astronauts also experience sounds transmitted through their bodies, a phenomenon called bone conduction. Vibrations from movements, tools, or even the spacecraft itself can travel through their suits and bones directly to their inner ears. This means an astronaut might hear the faint clank of a tool or the subtle hum of the spacecraft's engines, not through the air, but through their own body. It's a kind of sound that feels less like hearing and more like sensing. The environment inside a spacesuit can also affect how astronauts perceive these sounds. The helmet acts like a small chamber where sounds can echo or amplify slightly. This sometimes leads to an experience described as a headphone effect, where the internal noises feel close, intimate, and amplified. For some, this can be soothing. For others, it can be distracting or even unsettling during long spacewalks. Astronauts training for spacewalks on Earth often practice wearing their suits in giant pools of water, simulating the weightlessness of space. Even then, they notice these internal sounds, the familiar rhythm of breathing, the mechanical hum, and the faint voice of their instructors coming through radios become part of the experience, anchoring them amid the unfamiliar sensation of floating. Inside the spacecraft itself, the auditory environment is very different. The International Space Station, for example, is filled with constant mechanical sounds, fans, pumps, clicking switches, and the low hum of life support systems. These sounds form the background soundtrack of daily life in orbit, providing a sense of normalcy and continuity. Astronauts often say that this background noise, while sometimes tiring, helps maintain their psychological well-being by masking the profound silence just beyond the walls. The way astronauts perceive sound in space reveals a delicate balance between isolation and connection. Outside, the universe is vast and silent, But inside their suits and ships, they carry the sounds of life, breathing, heartbeats, machines' voices. These sounds link them not only to their immediate surroundings, but also to Earth, their home, and the millions of people watching from afar. It's a reminder that while space might be the ultimate frontier, the human experience there is deeply rooted in sensory details. Sound inside a spacesuit becomes a lifeline, a thread of familiarity amid the alien. It keeps astronauts grounded, calm and aware, even when surrounded by the greatest silence imaginable. So, when you imagine an astronaut drifting in the endless void, remember this. Though the universe itself is mute, inside their helmets they carry a personal universe of sounds, the soft whisper of their breath, the hum of their suit, the crackle of a radio call, all echoing the quiet, persistent heartbeat of human life itself. Inside the International Space Station, the silence of the cosmos gives way to a very different kind of soundscape, one filled with the steady, constant hum of human technology and life. Although the vastness of space outside is utterly silent, within the walls of the ISS there is an orchestra of mechanical noises, subtle vibrations, and quiet reminders of the delicate balance that keeps astronauts alive and comfortable hundreds of kilometers above Earth. Unlike a cozy home or even a busy office, the sounds inside the space station are mostly generated by machines. Fans whir continuously, circulating air to prevent carbon dioxide buildup and to regulate temperature. Pumps hum quietly as they move water and other vital fluids through the station's life support systems. The gentle vibrations of electrical equipment and scientific instruments create a low, omnipresent background noise that fills every corner. These sounds might seem mundane, but for astronauts, they are crucial. The humming fans and pumps are like a heartbeat for the station, signalling that the systems are functioning correctly. Without them, there would be no breathable air, no temperature control, no recycling of water. These sounds are the comforting, steady rhythm of life in space, a constant assurance that the station remains a safe haven amid the vast emptiness outside. Astronauts often describe the ISS as having a unique acoustic personality. It's not silent like space itself, but it's also not loud or chaotic like a city. Instead, the station produces a kind of white noise, a mixture of sounds that never quite change but never become dull either. This ambient hum can be surprisingly soothing after a while, much like the gentle roar of ocean waves or the steady buzz of a fan on Earth. It creates a sense of normalcy in an environment that is otherwise extraordinary. But not all sounds inside the ISS are mechanical. The astronauts themselves contribute to the station's soundtrack. Their footsteps on the metal floor plates, the faint rustle of clothing as they float and move, the soft clicks of buttons and switches, all add human texture to the environment. Even conversations, laughter, and the occasional music playing over the station's communication system fill the air, reminding everyone on board that they are still connected to the world below. Interestingly, because of the microgravity environment, sound behaves a little differently inside the station. With no up or down, and with floating objects everywhere, sounds can seem to come from unexpected directions. The metal walls, instruments, and equipment transmit vibrations in unusual ways, creating an immersive, three-dimensional sound experience. Astronauts have reported that sound can seem to wrap around them or bounce unpredictably, making it necessary to adjust how they listen and communicate. The station's acoustics also pose challenges. The constant hum of fans and machinery, while reassuring, can interfere with clear communication. That's why soundproofing and noise reduction are carefully considered in the station's design. Engineers use special materials to absorb or deflect unwanted noise, aiming to create an environment where astronauts can rest and focus without distraction. After all, too much noise, even a low, constant hum, can lead to fatigue and stress over time. Despite these efforts, the station can never be truly silent. The systems that keep astronauts alive always make some noise. For many crew members, these sounds become a comforting background track, a reminder of the technology working tirelessly to support human life in the harshest of environments. Beyond the routine noises, the station occasionally produces unique sounds tied to specific events. The opening and closing of airlocks, for example, generate distinct pressure changes that can be heard by those nearby. The whir of robotic arms or scientific experiments switching on or off adds variety to the station's soundscape. Even small impacts, like a tool bumping against a panel or a floating object tapping a wall, create faint but noticeable noises that remind astronauts of their presence in a real physical space. Astronauts also use these sounds as cues during critical moments. For example, the change in fan noise might signal a shift in ventilation or temperature control. The hum of a particular instrument might indicate it's collecting data. Being attuned to these acoustic signals becomes part of daily life, an important way to monitor the health of the station and its systems. In a way, the sounds inside the ISS are a testament to human ingenuity and adaptation. They show how we have transformed an inhospitable void into a livable home, using technology not only to survive, but to thrive. The hum of the fans, the buzz of the electronics, the faint echo of footsteps, they are the soundtrack of human exploration, a quiet symphony played out hundreds of kilometers above our blue planet. And while astronauts may sometimes yearn for the natural sounds of Earth, the rustling of trees, the songs of birds, the patter of rain, they come to appreciate the station's unique acoustic environment. It becomes a place where silence and sound blend in a delicate balance, a reminder that even in the cold emptiness of space, life can create its own kind of music. So next time you imagine the International Space Station orbiting silently overhead, remember that inside its walls, there's a gentle hum of machines and people, a living pulse beating in the heart of the cosmos. It's not the roar of engines or explosions you might expect, but a soft, steady chorus that keeps astronauts connected, alert, and alive, an invisible melody carried on waves we can't hear from Earth, yet one that makes space feel a little more like home. In the vast emptiness of space, where sound as we know it cannot travel, NASA and other space agencies have developed ingenious ways to listen to the cosmos. Since sound waves require a medium, air, water, or solids to propagate, and the vacuum of space provides none, scientists rely on different methods to capture and interpret the subtle signals that the universe sends out. These are not sounds in the traditional sense, but rather forms of energy that can be translated into audio that our ears and brains can understand. One of the primary tools NASA uses to hear space is through the detection of electromagnetic waves. Unlike sound waves, electromagnetic waves, such as radio waves, X-rays, and gamma rays, do not need a medium to travel. They can move freely through the vacuum at the speed of light. Spacecraft and satellites equipped with specialized instruments capture these waves emitted by stars, planets, black holes, and other celestial bodies. For example, radio telescopes on Earth and instruments aboard space probes pick up radio emissions from the sun's solar wind, streams of charged particles constantly flowing outward from the star. These emissions can be converted into audible sounds by shifting their frequencies into the range humans can hear, a process known as sonification. What emerges is a haunting, eerie symphony, whistles, crackles, and whooshes that represent the dynamic and ever-changing environment of our solar neighbourhood. Beyond solar wind, scientists monitor the magnetic fields that permeate space. When charged particles interact with these fields, they generate fluctuations that spacecraft can measure. These magnetic vibrations can also be sonified, offering an auditory glimpse into phenomena like solar storms or the boundaries of planetary magnetospheres. Listening to these translated sounds helps researchers better understand space weather and its potential impact on Earth and technology. NASA's Voyager spacecraft provide another remarkable example. As they journeyed beyond our solar system, the Voyagers carried instruments designed to capture plasma waves, oscillations in the ionized gas surrounding planets and stars. When these waves were converted into sound, they produced strange, otherworldly melodies, sometimes likened to whale songs echoing through the vastness of space. These recordings, while not sounds in the conventional sense, offer a poetic bridge between the silent cosmos and our sensory experience. In addition to plasma waves, NASA has used radar and LiDAR, light detection and ranging, to map surfaces of planets and moons, sending pulses of electromagnetic radiation and measuring their reflections. While this technique is primarily visual and spatial, scientists have experimented with turning the data into sound to reveal subtle variations and patterns invisible to the eye. This auditory approach can enhance understanding by engaging different senses. Sonification has become a powerful scientific and artistic tool, turning data from the invisible universe into audible experiences. It allows us to experience the rhythms and patterns of cosmic phenomena in a way that transcends pure visual observation. Scientists can detect anomalies, patterns, or changes by listening to the data, sometimes more intuitively than by looking at graphs or images. Moreover, space agencies use this method to help the public connect emotionally with the cosmos. By hearing the sounds of space, the solar wind, pulsars, black holes, or the vibrations of distant planets, people can feel a closer bond to the universe. The cold, silent void becomes more alive and accessible. Besides electromagnetic waves, NASA also uses gravitational waves as a form of cosmic signal. These ripples in space-time, caused by cataclysmic events like colliding black holes or neutron stars, were first directly detected in 2015. Although they cannot be heard in space, scientists convert the frequencies of these waves into audible sounds. The resulting tones offer a thrilling and profound new way to listen to the universe's most violent and mysterious occurrences. It's worth noting that all of these auditory translations require sophisticated technology and interpretation. The original sounds in space are often outside human perception, too high, too low, or too faint to detect naturally. By carefully processing and shifting the data into our hearing range, NASA enables us to perceive something that would otherwise remain completely silent. In essence, NASA and other space agencies have transformed space into a kind of cosmic concert hall. They take the invisible waves and vibrations that fill the universe and turn them into music, complex, mysterious, and endlessly fascinating. This music is not just for pleasure, it is a tool for discovery, a way to understand the behavior of celestial bodies, the dynamics of the solar system, and the very fabric of the cosmos. So while you cannot hear a spaceship zooming by, or a star exploding in the vacuum of space, you can hear the echoes of those events through the instruments that translate the language of the universe. These carefully crafted sounds remind us that space, though silent in the traditional sense, is filled with activity and movement. An orchestra playing a symphony billions of years in the making, waiting for us to listen. Even though space is a vacuum where traditional sound waves cannot travel, there are other ways to sense vibrations and hear phenomena beyond the limits of our ears. This opens a fascinating window into how sound and sensation are not always tied strictly to air or other mediums. Instead, vibration, the fundamental source of sound, can be experienced in different forms, sometimes through direct contact or alternate physical channels, allowing us to perceive what would otherwise be silent. On Earth, we're accustomed to hearing sound through air, but we also often experience sound through touch and vibration. For example, when you place your hand on a speaker or a drum, you feel the powerful vibrations produced by the instrument. Those vibrations are essentially sound waves travelling through the solid material, and while they may be inaudible to your ears, your skin and bones pick up the rhythmic pulses. This phenomenon, known as bone conduction or tactile hearing, allows us to experience sound in more than one way. In space, where there is no air to carry sound waves, similar principles apply. While the vacuum itself cannot transmit sound, vibrations can travel through physical objects, spacecraft structures, spacesuits, or even an astronaut's own body. These vibrations become a crucial form of communication and awareness in an environment where typical hearing is impossible. For instance, if an astronaut taps their helmet or suit, the resulting vibrations travel through the solid materials and can be felt or even heard internally. The bones of the skull and the fluids in the inner ear can transmit these vibrations directly to the cochlea, bypassing the eardrum entirely. This means an astronaut can perceive sounds through bone conduction even when traditional airborne sound is absent. This effect is not just a curiosity, it plays an essential role in how astronauts monitor their environment. For example, tools or equipment attached to the suit or spacecraft can generate vibrations during use. These vibrations can inform astronauts of mechanical functioning, warn of malfunctions, or provide tactile feedback when visual cues are limited. It's a subtle but vital form of sensing that complements other instruments and communication systems. Vibration also plays a role in spacecraft design and operation. Engineers carefully consider how vibrations move through the metallic frames of vehicles and stations. Certain vibrations can indicate stress or damage in structures, much like how a doctor might listen to the sound of a heartbeat or a broken bone. Sensors placed on spacecraft detect these vibrations, allowing ground control and astronauts to monitor the health of their machines without relying on sound in the air. Beyond human-made structures, vibrations in space can occur on a cosmic scale as well, though we don't hear them directly. For example, large celestial objects like stars and planets experience oscillations and pulsations, tiny vibrations that ripple through their interiors. Scientists study these vibrations through a field called asteroseismology. By analysing how these vibrations affect the light emitted by stars, researchers can learn about their inner composition and life cycles, much like how geologists study earthquakes to understand Earth's interior. While these cosmic vibrations cannot propagate through the vacuum as sound waves, their indirect effects can be detected by instruments and translated into data we can interpret. In some cases, scientists have converted these signals into audible frequencies, allowing us to listen to the pulsations of stars or the ringing of neutron stars, bringing these distant cosmic dances into our sensory realm. Another fascinating way vibration manifests in space is through gravitational waves, ripples in the very fabric of space-time caused by massive cosmic events like colliding black holes or neutron stars. While not sound in the traditional sense, these waves carry energy and information across the universe. Detectors on Earth, such as LIGO and Virgo, pick up these faint vibrations, and scientists convert the signals into sounds we can hear, opening a new way to experience the universe's most violent and energetic moments. On a more immediate, human level, astronauts themselves can sense vibrations transmitted through their suits or the spacecraft structure. These subtle physical cues can be reassuring or alarming. Feeling the gentle tremor of a system functioning normally can provide comfort. Conversely, unexpected vibrations might signal an anomaly, alerting the crew to potential problems even before visual indicators or alarms go off. These vibrations create a kind of silent language, a tactile form of communication between astronaut, suit, and machine. It's an intimate connection that enhances safety and situational awareness in a world where traditional sound simply cannot reach. The idea that sound and vibration can be separated, that one can be felt even without the other, is a powerful reminder of the diversity of sensory experience. Our perception is not limited to what our ears can catch. Our bodies are sensitive instruments capable of receiving and interpreting many forms of energy and movement. In this way, space challenges us to expand our understanding of hearing and sensing. It invites us to imagine a world where sound might not travel through air, but where the universe still pulses, vibrates, and moves in ways we can detect, if only we listen differently. So while space may be silent to our ears, it is never truly without vibration. The hum of a spacecraft, the gentle pulse of a heartbeat, the subtle tremor of a tool, or the far-off ringing of a star. All these vibrations form a hidden soundtrack. They remind us that even in the vacuum, life and motion persist, whispering their secrets not through sound waves, but through the subtle language of vibration felt deep within. As we continue to explore the mysteries of space, one of the most captivating discoveries is the variety of sounds, or rather, vibrations and electromagnetic signals, that scientists have managed to capture from other worlds and cosmic phenomena. Though space itself remains silent in the traditional sense, technology allows us to translate these signals into audible forms, revealing an eerie and haunting world of cosmic sounds emanating from planets, moons, and deep space itself. Planets within our solar system, though surrounded by the vacuum of space, often generate unique electromagnetic emissions. For example, Jupiter, the largest planet in our neighbourhood, is known for producing intense radio waves caused by its powerful magnetic field interacting with charged particles. Spacecraft like NASA's Juno mission have captured these radio emissions, which scientists then convert into sounds we can hear. The resulting audio is a strange blend of crackling static, whooshes, and rhythmic pulses, like the alien music of a colossal cosmic orchestra. Saturn, with its mesmerizing rings and many moons, also produces similar emissions. The Cassini spacecraft, which orbited Saturn for over a decade, recorded radio waves and plasma oscillations created by interactions between the planet's magnetic field and the solar wind. When translated into sound, these data reveal pulsating tones and swirling frequencies that evoke the vast, dynamic environment of the ringed giant. Beyond our solar system, distant pulsars, rapidly spinning neutron stars, emit beams of electromagnetic radiation at precise intervals. When these signals are converted to sound, they produce a rhythmic, pulsing, or beeping that scientists often liken to a cosmic lighthouse, steadily sending its message across the void. These pulsar sounds are not just fascinating, they serve as vital cosmic clocks that help astronomers study the structure and history of our galaxy. Even black holes, known for their all-consuming darkness, have been given a voice through these techniques. Though black holes themselves emit no light or sound, the regions around them can produce powerful X-rays and radio waves as matter accelerates and heats before being swallowed. Observatories such as the Chandra X-ray Observatory have captured data that, when sonified, produce eerie, deep tones, sometimes described as the sound of a black hole's surroundings. These sounds remind us that even the darkest corners of the universe are alive with energy and activity. Closer to home, planets like Mars have provided unique audio opportunities. NASA's Perseverance rover carries microphones that have recorded the sounds of Martian winds, the rover's mechanical operations, and even the subtle vibrations caused by its laser zapping rocks. These recordings give us a glimpse of a world that feels distant and alien, but also surprisingly familiar. The gentle hiss of wind across Martian dunes, or the soft clicks of machinery, bring Mars to life, in a way images alone cannot. Venus, with its thick, swirling atmosphere, is another source of interest. Though direct recordings are scarce due to the planet's harsh environment, scientists have used radio telescopes to pick up electromagnetic signals influenced by Venus's dense atmosphere and magnetic interactions. By converting these signals, researchers have created eerie soundscapes that hint at the turbulent, high-pressure world hidden beneath the clouds. Beyond planets and stars, entire regions of space teem with electromagnetic activity. Nebulae, the vast clouds of gas and dust where stars are born, emit radio waves that can be detected by telescopes on Earth. These waves, when translated into sound, create ethereal, flowing tones that seem to echo the creative energy of the cosmos. It's as if the universe is humming a quiet lullaby as it crafts new stars and planets. In addition to electromagnetic data, scientists have turned to seismic vibrations on other worlds to explore sound in different ways. For instance, NASA's InSight lander on Mars has detected Marsquakes, subtle tremors within the planet's surface. While these aren't sounds travelling through an atmosphere, they are vibrations transmitted through the solid ground. By converting these seismic data into audio, scientists can listen to the heartbeat of Mars itself, gaining insight into its interior and geological activity. All of these recordings, whether from radio waves, plasma oscillations, seismic activity, or electromagnetic emissions, offer a new way to connect with worlds far beyond our own. They reveal that, although space is silent in the traditional sense, it is far from empty or lifeless. Instead, the universe is filled with a symphony of invisible waves and vibrations, constantly shifting and evolving. These cosmic sounds challenge us to expand our understanding of what it means to hear. They invite us to listen not only with our ears, but with our instruments, our technology, and our imagination. Through these translations, distant worlds become less remote, more tangible. We can experience their rhythms, their pulses, their subtle messages in a form that resonates with our human senses. Perhaps most profoundly, these sounds remind us of the interconnectedness of all things. The radio waves from Jupiter's magnetosphere, the rhythmic pulses of a neutron star, the subtle tremors of Martian soil, they all form part of a grand cosmic conversation. Each vibration, each wave, is a thread in the vast tapestry of the universe, waiting for us to tune in and listen. So, as we gaze up at the night sky, sparkling with countless stars and planets, we can take comfort in knowing that these distant worlds are not silent after all. They are alive with sound, just beyond the reach of our ears, yet captured by the marvels of human curiosity and technology. In their haunting melodies and rhythmic pulses, the universe offers us a glimpse of its hidden music, inviting us to explore, to dream, and to listen with wonder. For centuries, the idea of the music of the spheres has captured human imagination, a mystical concept suggesting that the movements of celestial bodies create a kind of cosmic harmony. Originating in ancient philosophy, this notion proposes that the planets and stars, as they orbit and rotate, generate rhythms and vibrations that form a celestial music, one that is inaudible to human ears, but deeply woven into the fabric of the universe itself. The philosopher Pythagoras first introduced the idea that the cosmos was governed by mathematical relationships akin to musical intervals. He believed that the proportions governing planetary motions corresponded to harmonious musical ratios, creating an invisible symphony. Later thinkers, from Plato to Johannes Kepler, expanded on this vision. Kepler in particular sought to understand the motions of planets through harmonic laws, describing the distances and velocities of planets in terms of musical intervals and harmonies. Though modern science no longer supports the literal idea that planets emit music, the metaphor remains powerful. In fact, there is a modern scientific resonance with the concept, though not in sound waves but in vibrations and frequencies that can be measured and translated into audible forms. Planets and stars are not silent objects. They pulsate, vibrate, and oscillate. These vibrations arise from internal processes, gravitational interactions, and magnetic fields. For example, Stars undergo natural pulsations caused by the interplay of gravity and pressure within their interiors. These pulsations produce waves that ripple through the star's structure, subtly changing its brightness and spectral lines in rhythmic patterns. Scientists study these variations through asteroseismology, a field akin to seismology on Earth, but applied to stars. When these stellar oscillations are converted into sound waves within the range of human hearing, they produce a series of tones and rhythms that can be perceived as a kind of music. The frequencies often resemble haunting melodies, ethereal and otherworldly, evoking the idea that the stars themselves are singing. Similarly, planets have their own vibrational signatures. Our Earth rings after large earthquakes, producing waves that circle the planet like a bell. Other planets, like Jupiter and Saturn, generate complex electromagnetic waves in their magnetospheres. When scientists translate these signals into audio, the result can sound like eerie, space-age music, sometimes described as whistles, pulses, or deep drones. The music of the spheres also extends metaphorically to the elegant mathematical harmonies underlying the universe. The fundamental laws of physics, gravity, electromagnetism, quantum mechanics, can be expressed through wave functions, frequencies, and oscillations. This mathematical music is the language through which the cosmos operates, governing the dance of galaxies, stars, and atoms alike. Modern physicists sometimes speak of the universe in terms of vibrations and resonance. String theory, for instance, proposes that the fundamental building blocks of reality are tiny vibrating strings, each frequency corresponding to a different particle or force. In this sense, the universe is quite literally composed of music, though at a scale far beyond our direct perception. In art and science, musicians and researchers have collaborated to create soundscapes inspired by cosmic data. By translating electromagnetic waves, pulsar signals, and gravitational waves into sound, artists bring the ancient idea of the music of the spheres into the modern era. These compositions blend science with creativity, turning the data of the cosmos into immersive experiences that touch both the intellect and the soul. The psychological and spiritual allure of the music of the spheres is profound. It suggests that the universe is not a cold, indifferent void, but a living, resonant entity, one in which harmony and order underpin even the most chaotic phenomena. This idea encourages us to see ourselves as part of a larger whole, connected through invisible threads of vibration and rhythm. Some spiritual traditions echo this concept, viewing sound as a fundamental creative force. The idea that the universe began with a cosmic vibrational sound, like the Hindu concept of Om, or the biblical Let There Be Light, ties creation to resonance and music. These ancient teachings align surprisingly well with modern physics' understanding of the universe's vibrational nature. As we listen to the sonified data from stars, planets, and galaxies, we tap into this timeless human longing to hear the universe's song. It is a call to wonder, to awe, and to connection. The music of the spheres may not be audible to our ears in the classical sense, but through science and imagination, we can experience a glimpse of that celestial harmony. In the end, the music of the spheres reminds us that the cosmos is a symphony of motion and energy, an endless dance of light and vibration. Whether through the rhythmic pulses of a distant pulsar or the gentle hum of our own planet. The universe sings a song that transcends words, a song inviting us to listen, to learn, and to marvel at the beauty of existence itself. Among the countless wonders of our planet, Earth itself holds a unique place in the cosmic symphony, not only as our home, but as a source of sound that travels beyond its atmosphere into the vastness of space. From the perspective of space, Earth is not a silent orb. It is alive with countless vibrations, rhythms, and pulses that tell stories of life, movement, and dynamic processes. Understanding what Earth sounds like from space offers us a profound connection to our planet and a glimpse into the intricate interplay between atmosphere, geology, and life. From satellites orbiting above, scientists have captured a fascinating array of audio data that reveal the planet's diverse soundscape. While space itself remains silent, instruments on board these satellites record electromagnetic emissions, radio waves, and other signals generated by natural and human-made phenomena on Earth. When these signals are converted into audible forms, they paint a vivid portrait of our world's energetic heartbeat. One prominent example is the sound of Earth's magnetosphere, a protective magnetic bubble generated by the movement of molten iron in the planet's core. This magnetic field shields us from the solar wind, a stream of charged particles flowing from the sun, and in doing so produces fascinating electromagnetic interactions. Instruments like those aboard NASA's Themis mission have recorded plasma waves and electromagnetic emissions in this region, which, when sonified, become haunting, otherworldly sounds. These recordings give us a sense of the invisible forces constantly at play around our planet, forming a protective cocoon that sustains life. The atmosphere itself is another source of rich acoustic phenomena. Thunderstorms generate powerful electrical discharges that emit radio waves detectable from space. These signals, often called spherics, can be transformed into sharp crackles and pops, reminders of the immense energy and dynamic weather systems swirling in our skies. Beyond storms, even the steady movement of air in the form of winds creates subtle electromagnetic signatures, allowing us to hear the breath of our atmosphere as it dances around the globe. Seismic activity on Earth also contributes to our planet's soundscape as heard from space. Large earthquakes cause the planet to ring like a bell, sending vibrations rippling through the ground and indirectly into the surrounding environment. While these are not sound waves travelling through air, sensitive instruments can detect their effects in electromagnetic and seismic data. Scientists have used these signals to monitor tectonic activity and better understand Earth's internal structure. In addition to natural phenomena, human activity contributes to the planet's detectable soundscape. Radio signals from communication networks, the hum of electrical grids, and even the vibrations caused by large machinery and transportation systems produce electromagnetic emissions that satellites can detect. Though faint compared to natural sources, these human-made signals reveal the extent of our presence and influence on the planet. One of the most remarkable projects connecting Earth's sounds to space was the creation of the Voyager Golden Record. Launched aboard the Voyager 1 and 2 spacecraft in 1970, this phonograph record carries a carefully curated collection of sounds and music from Earth, ranging from natural sounds like thunder, bird song, and whale calls to human-made music and greetings in multiple languages. The golden record serves as a message to any intelligent life that might encounter the spacecraft, a way of sharing the sonic essence of our world as it journeys into the unknown reaches of space. Listening to these sounds, we gain a deeper appreciation for Earth's complexity and vitality. Our planet is not merely a silent, inert rock floating in space, but a vibrant, ever-changing entity alive with movement and energy. From the crackle of lightning storms to the deep hum of the magnetosphere, Earth's sounds tell the story of a dynamic planet teeming with life and activity. These recordings also remind us of our responsibility as stewards of this precious world. Hearing the delicate balance of natural processes and the subtle imprint of human activity encourages a sense of wonder and care. It prompts us to consider how our actions ripple outward, affecting not only ourselves but the broader environment. Moreover, understanding Earth's soundscape from space enriches our scientific knowledge. By monitoring electromagnetic and acoustic signals, researchers can track weather patterns, volcanic eruptions, geomagnetic storms, and other critical events in real time. This information helps improve disaster preparedness, climate modelling, and environmental management, illustrating how the sounds of our planet are intertwined with human safety and survival. In a poetic sense, hearing Earth from space bridges the gap between our immediate experience and the vast cosmos. It connects us to our home in a tangible, sensory way, even when we are looking at distant stars or pondering the silence of the universe. Earth's sounds become a reminder that no matter how far we travel or how deep we explore, we are rooted in a living, breathing world. In this way, the sound of Earth as heard from space is more than just data or curiosity. It is a celebration of life itself. It's a symphony composed by nature and humanity alike, a soundtrack to the story of our planet. And as we listen, we become part of that story, connected to the rhythms of Earth and the endless music of the cosmos. The Voyager Golden Record stands as one of humanity's most poetic and ambitious messages to the cosmos. A time capsule of sound, music, and greetings, carefully crafted to represent the richness of life on Earth and to communicate with any potential extraterrestrial listeners far beyond our solar system. Launched aboard the Voyager 1 and Voyager 2 spacecraft in 1977, these records are not only technical marvels, but also profound cultural artifacts, encapsulating the diversity, creativity, and spirit of our planet. The idea behind the Golden Record was simple yet profound. If one day these spacecraft were to be discovered by intelligent beings elsewhere in the galaxy, what message would we want to send about who we are? What sounds and images would best represent the vast complexity and beauty of Earth? This question was tackled by a committee chaired by the renowned astrophysicist Carl Sagan, who brought together scientists, artists, and musicians to create a selection that would be as inclusive and representative as possible. The record itself is a 12-inch gold-plated copper disc designed to withstand the harsh environment of space for potentially billions of years. Encoded on it are a variety of sounds from Earth, beginning with a greeting in 55 different languages, including ancient tongues and modern dialects, expressing goodwill and peace from our species. These greetings set the tone for the record's purpose, a friendly, hopeful outreach from humanity to the unknown. Following the greetings, the Golden Record carries a rich tapestry of natural sounds that paint an auditory picture of life on Earth. Listeners would hear the gentle roar of the ocean waves, the rhythmic tapping of rain, the crackling of a fire, the chirping of birds and the calls of whales singing their haunting melodies beneath the waves. These natural soundscapes serve as a reminder of Earth's diverse ecosystems, the rhythms of nature, and the interconnectedness of all living things. Interwoven with these natural sounds is an eclectic and profound collection of music from around the world. The selection spans cultures, genres, and centuries, showcasing humanity's artistic creativity and emotional expression, from classical masterpieces by Bach, Beethoven, and Mozart to traditional songs from the Navajo tribe, an Indonesian gamelan ensemble, and even modern jazz and blues. The Golden Record presents a sonic snapshot of human culture and history. This musical anthology is more than just entertainment. It is a language of emotion and beauty that transcends words. Music has the power to convey joy, sorrow, celebration, and spirituality, making it an ideal medium for communicating with beings who may never understand our spoken languages. Through melodies, rhythms, and harmonies, the record attempts to reach across the voids with shared feelings and experiences. In addition to sound, the Voyager spacecraft carry a detailed diagram illustrating the position of our solar system and instructions on how to play the record. This guide is intended to help any discoverers understand how to decode the signals and access the audio. It includes symbolic representations of hydrogen atoms and pulsars using universal scientific principles that may be recognized by advanced civilizations. The Golden Record also features images encoded in analog form, photographs and diagrams depicting life on Earth, our anatomy, architecture, plants, animals, and human activities. Together with the audio, these visuals offer a multi-sensory portrait of our world, providing context to the sounds and music. As the Voyager probes continue their silent journey outward, carrying this precious cargo beyond the heliosphere into interstellar space, the Golden Record stands as a hopeful testament to human curiosity, creativity, and the desire for connection. It reminds us that even as individuals and societies change, there is a collective voice speaking across time and space, seeking companionship and understanding. This endeavour also reflects humanity's deep longing to reach beyond itself, to find meaning and community in the vast universe. In a cosmos often perceived as cold and indifferent, the Golden Record embodies warmth, optimism, and the profound wish to be heard. In a way, the Golden Record transforms silence into song, emptiness into expression. It takes the quiet backdrop of space and fills it with the voices, sounds, and music of a small blue planet. It is a bridge between worlds, an invitation to listen, to learn, and perhaps one day to respond. For us here on Earth, the Voyager Golden Record serves as a powerful symbol, a reminder of our place in the universe and the shared humanity that connects us all. It encourages us to cherish the diversity of life and culture and to embrace the wonder of exploration. As these records drift through the silent stars, they carry the dreams and hopes of a species reaching outward, reminding us that even in the vastness of space, the sound of Earth still travels, waiting to be heard. The vastness of space invites endless questions about life beyond our planet. One of the most intriguing mysteries is whether there are beings out there who might be capable of hearing or perceiving sounds as we understand them, or if their sensory experiences would be fundamentally different from ours. If extraterrestrial life exists somewhere among the stars, the nature of their hearing or communication could challenge everything we think we know about sound and perception. On Earth, hearing depends on the presence of a medium, typically air or water, through which sound waves travel. But in the vacuum of space, sound cannot propagate in the usual way. This means that any life existing beyond our atmosphere would either have to inhabit environments with a medium for sound transmission, such as atmospheres, oceans, or dense planetary surfaces, or rely on entirely different mechanisms for sensing and communication. If alien creatures live on planets with atmospheres similar to Earth's, it's possible they have evolved auditory systems to detect sound waves in air or water, much like terrestrial animals. Their ears or analogous organs might be tuned to different frequency ranges, capable of perceiving sounds we cannot detect. They might communicate through complex vocalizations, songs, or even ultrasonic or infrasonic signals. However, the possibilities extend far beyond Earth-like conditions. Some scientists speculate about life forms existing in extreme environments, such as gas giants, icy moons with subsurface oceans, or even on rocky worlds with thin or no atmospheres. In such places, hearing might take forms completely alien to us. For example, life forms might rely on electromagnetic signals, detecting fluctuations in magnetic or electric fields rather than sound waves. They might hear through sensing vibrations transmitted by solid substrates, or use chemical signals and light pulses for communication. In these cases, their version of hearing would be radically different from human experience, perhaps akin to sensing the universe's hidden rhythms in a way we can barely imagine. The search for extraterrestrial intelligence, SETI, explores these ideas by scanning the cosmos for signals, radio waves, laser pulses, or other forms of electromagnetic communication that could indicate the presence of advanced civilizations. While not traditional sound, these signals represent a kind of cosmic conversation, encoded in frequencies and patterns that may be deciphered by beings capable of receiving them. Yet the question remains, if we ever do encounter alien life, will we be able to communicate? Will they understand our sounds, music, or language? Or will we need to find new ways to bridge the gap between species and sensory worlds? These questions highlight the vast diversity that life might take, and challenge us to expand our definitions of perception and connection. On a more philosophical level, pondering alien hearing invites us to reflect on the nature of communication itself. Sound is just one channel of information among many. Touch, light, chemical signals, and even electromagnetic waves all carry messages. Life throughout the universe may be attuned to frequencies and vibrations that transcend our human senses, speaking in languages of resonance and rhythm that are beautiful and profound, but utterly unfamiliar. Imagining these possibilities encourages humility and wonder. It reminds us that our experience, while rich and complex, is just one of countless ways to perceive reality. The universe may be filled with countless beings listening to their surroundings in ways we cannot yet comprehend, tuned into the silent music of the stars through senses beyond sound. This reflection leads naturally into a sobering question. What if you screamed in space? Would anyone hear you? The answer is a definitive no. Without air or another medium, Your scream would not travel. It would be trapped in your own vocal cords, unable to escape the vacuum. Your voice would vanish, swallowed by silence. This fact is often depicted dramatically in science fiction, where characters shout in space and are heard through the void. But in reality, the vacuum is unforgiving to sound. This silence adds to the alien nature of space, reminding us that our familiar ways of communicating and perceiving are intimately tied to Earth's environment. But the question also invites a deeper reflection on fear and survival. The idea of screaming into the void and being unheard is a powerful metaphor for isolation and vulnerability. In space, the absence of sound amplifies feelings of loneliness, emphasizing the vast separation between us and the cosmos. Yet even in that terrifying silence, life endures. Astronauts do not scream. They communicate through radios, through vibrations transmitted via equipment, through signals that transcend air. Their survival depends not on raw sound, but on technology, ingenuity, and connection. This quiet resilience echoes in our own lives. When faced with moments of helplessness or fear, we may feel as if our cries go unheard. But like astronauts in the void, we find other ways to reach out, through gestures, through shared understanding, through the subtle vibrations of empathy. Finally, as we close our journey through the silent beauty of space, we come to a gentle farewell, a moment to rest, reflect, and let the stillness wash over us. The cosmos invites us into its vast, quiet embrace, where the absence of noise becomes a space for thought, for dreaming, for peace. In this silence, we are free from the distractions and chaos of daily life. We can breathe deeply, let our minds drift among the stars, and find comfort in the endless night sky. The quietude of space is not emptiness but fullness, a canvas upon which imagination and wonder paint their most delicate strokes. As you settle in, feel the gentle pull of gravity fade, the world grow still, and the universe stretch endlessly around you. Let the silence cradle you like a soft lullaby, a cosmic whisper inviting you to rest. May this quiet night carry you gently into dreams, where stars sing softly, and the music of the spheres plays just beyond the edge of hearing. Good night, cosmic wanderer. Your journey has only just begun.